হ্যাঁ হ্যাঁ,
ঠিক আছে,
দিয়ে শুরু করে দিন তাহলে।
सर्वे भवन्तु सुखिनः, सर्वे भवन्तु निरामया, सर्वे भद्राणि पश्यन्तु, मा कश्चित् दुःखभाग् भवेत्, मा कश्चित् दुःखभाग् भवेत्. Professor Ramprashad Sengupta, Professor Soumyen Sikdar, distinguished guests, friends, and members of AACUED fraternity. I have great pleasure in extending a warm and hearty welcome to all of you to the second Professor Arup Mallik Memorial Lecture this evening. This lecture is being organized on Teachers' Day as a tribute to Professor Arup Mallik, an iconic teacher of Economics Department of Calcutta University. Today amongst us, we have distinguished panelists to deliberate on extreme events, neo-Malthusianism, and challenges of sustainability. We are grateful to Professor Ramprashad Sengupta, Professor Emeritus of Economics, Jawaharlal Nehru University, for kindly accepting our invitation and sparing his valuable time to deliver this lecture this evening. We are also thankful to Professor Soumyen Sikdar, Professor IIM Calcutta, for kindly agreeing to moderate this session. You are all aware that Alumni Association of Calcutta University Economics Department, AACUED, was founded in 2001 to provide a platform of knowledge and networking to all the former and current students of Calcutta, the reputed economics department of University of Calcutta. In this journey, AACUED has organized many seminars and debates on contemporary issues and have also brought out rich publications. They also have stood by meaningfully with philanthropic financial supports to the community at the appropriate time of their need for the deserving. Professor Arup Mallik Memorial Lecture is one of the flagship events of AACUED. The first lecture was delivered on 21st September 2019 by Professor Paranta Basu of Durham University. The late Professor Arup Mallik was an economist and an educationist par excellence who needs no introduction among his students. He studied in University of Calcutta and did his PhD work at the University of Rochester. He earned coveted prizes throughout his academic career. He gained the reputation of an extraordinary teacher to entire student community. His teachings on microeconomics, trade theory, and the last but not the least, Marxian value theory remain an unforgettable experience among the generations of his students. Many of his students grew up into successful researchers in the established sense, earning worldwide acclaim. The inheritance from their master has always been recognized by them with the gratefulness in their heart of hearts. Professor Ramprashad Sengupta, Emeritus Professor of Economics, Jawaharlal Nehru University, is an internationally reputed environmental economist who pioneered the research on environmental economics in India. He taught at the Center of Economic Studies and Planning, JNU, over a few decades. He also taught in different universities in US, Japan, Canada, Germany, and Netherlands. He was Mahatma Gandhi National Fellow of ICSSR till 2018. He is former advisor to the Planning Commission, Government of India. He is also former professor of economics at the Indian Institute of Management, Calcutta. He also held position of independent director on the board of Steel Authority of India Limited, SAIL. He is writing on economy, ecology, and economics, anthropology, law, sustainability are the universally accepted scholarly contributions. Professor Soumyen Sikdar did his graduation from the University of Calcutta in economics and did his PhD from University of Minnesota, US. He taught at different organizations of repute, including University of Calcutta, Burdwan University, and XLRI Jamshedpur. Now he is Professor of Economics at IIM Calcutta. He has been a visiting professor at Institute of Social and Economic Research, Osaka University, Japan, Indira Gandhi University Institute of Development Research, Mumbai, Center of Economic Studies, Presidency College, Calcutta. With this, I invite all the existing members of AACUED and the prospective ones to come forward and make the endeavor of our organization successful. We need each and one of you to strengthen our fraternity and take the mission of AACUED forward to greater heights. Thank you very much for giving me this honor and also lending me your patient hearing. Thank you very much.
Thank you very much, Mr. President, sir. May I now invite Professor Soumyen Sikdar to kindly take over from here. I would request Professor Sikdar to introduce the topic and also to start the proceedings of the second Professor Arup Mallik Memorial Lecture to be delivered by Professor Ramprashad Sengupta. Professor Sikdar, sir, please.
Okay, I start by thanking AACUED for organizing this, honoring a great teacher on Teachers' Day particularly, and for inviting me to be the moderator of this session. It's a matter of great fortune for us that Professor Ramprashad Sengupta, who I have known for a very long time since my college days, that he is the speaker now, and as has already been pointed out, he is an acknowledged expert in this area. And the topic is extreme events, neo-Malthusianism, and challenges of sustainability. And this topic is particularly relevant today and topical because in it he will also be talking about, he will be linking the current corona pandemic with the disaster of ecology that we humans have imposed, or rather perpetrated on the natural world. So I am sure it will be a very exciting lecture by an acknowledged expert in the field. And just let me point out that Professor Sengupta will be speaking for 1 hour, and that will be followed by question and answer for 30 minutes. And one request, if you want to make comments or ask questions, it will be better if you type that in the chat box so that I can see who wants to speak and so on. So that's my request. And of course, request is you should be brief and to the point. You shouldn't be giving another lecture of your own, which people have a tendency to do on these occasions. With this, I invite our Ramprashad Da, my Ramprashad Da, to deliver his lecture. Ramprashad Da?
Yes. Thank you. Thank you.
You still other than the speaker, everybody.
That's good. First of all, thank you, Soumyen. Thanks for the nice compliments and words about me from both the president of the Alumni Association, Mr. Swapan Ganguly, and also from now the present chair or moderator, Professor Soumyen Sikdar. I hope I am properly audible to all of you.
Yeah, you are very much.
Okay. I met, let me start straight. I met Professor Arup Mallik for the first time sometime in 1966 or 67 when I was a student of MA class in Calcutta University. He was academically 2 years senior to me and a respected professional colleague, a personal friend, and a genuine well-wisher. In the days of 70s, when I was a doctoral and then a postdoctoral researcher in Calcutta, I used to frequently meet him in his office in the economics department of Calcutta University at Cantakol or in his Maniktala house for thinking aloud any new research idea which occurred to me to see or check if it made sense to him. Looking back to those days, I feel overwhelmed to recall with what kind of patience and huge affection he used to listen to me and discuss the issues always with positivism. Apart from that, he was a very socially and politically conscious intellectual and an affectionate friend of many of our generation. I remember the days when Professor Arup Banerjee, I think present here, former VC of Calcutta University, Somnath Sen, now of Birmingham University, and myself were regular visitors to Arup's Maniktala house, where we used to have adders and debates over hours on any range of issues. These remembrances overwhelm me today, seeing how time plays a widely different role in our life compared to those days as the technology and society change over time and deeply influence our values and way of life and thought. I am grateful to the Alumni Association of the Economics Department of Calcutta University and particularly to its president, Mr. Ganguly, and Secretary, I think, Dr. Arup Mukherjee, for giving me this opportunity of paying my tribute to the memory of Professor Arup Mallik, our beloved Arupda, who was an iconic teacher, wonderful exponent of any complicated conceptual issue of economic theory, especially classical political economy, and above all, one of the finest human beings I ever met. I am personally a believer in the immortality of soul. I would like to believe that our collective remembrance and on Teacher's Day would reach him wherever he might be in this cosmic universe. Today, I pay to the memory of pay tribute to the memory of Professor Arup Mallik. I shall talk on extreme events, neo-Malthusianism, and challenges of sustainability. I shall begin by narrating a few recent extreme events in nature and the human society, including the current pandemic, COVID-19, which has caused an existential crisis for the whole humanity. I would like to point out that the common driving factor behind many of these extreme events has been the unfolding of the imbalance between human appropriation of natural resources of the Earth's ecosystem, which we call ecological footprint, and the carrying capacity of the biosphere, which we call biocapacity of the Earth, to provide support to such human demand. The extreme events convey, in fact, as we shall see, a neo-Malthusian message which poses a challenge of sustainability for the humanity at this current juncture of crisis. Humanity is currently facing today a huge existential crisis due to the coronavirus disease pandemic caused by the highly infectious nature of the disease. Although the world is still in the midst of the pandemic, and we cannot as yet make a total assessment of its impact and derive sustainability policy implications, all the countries of the world are already affected by this pandemic in such a manner that their socio-economic life has been derailed from its normal course of movement. The total number, I will just give only a limited number of data. The total number of cases of infection worldwide due to the COVID-19 reached 2,44 lakhs as on 27th August, out of which 8 lakh people already died. I show in the following slide the rapid rise in the total number of active cases worldwide, which includes deaths and recovered or discharged patients. Now this figure has reached 66 lakhs as of 27th August. You can see the slide, the graph, I hope. Okay. Is it visible?
Yes, yes, very much. Yes.
Okay. Okay. Now you just see, till the month of March, it was almost at the axis. The number was very small, but then sharply it has risen, and now it has risen up to the 244 lakhs as of 7 days back. Now, India, among all the countries, India is in the third position among the countries in the world in terms of total number of cases of infection as on the same date, 27th August. At the start of the official lockdown on 25th March, the total number of confirmed cases in India stood at only 563, which spiked to more than 33 lakhs as on 27th August. Out of this, 60,000 people died. The fast growth of infected disease and the extent of its spread and fatality, as experienced in India, reveal the seriousness of its prevalence among population, among the people, and the high risk of life involved in the disease. Next question is, why this pandemic? What's the reason? Since the spread of the disease COVID-19 is from physical contact among humans, one may suppose if pressure of population density or any Malthusian imbalance between population size and food supply is any significant factor of the rate of prevalence of the disease. My empirical investigation with my former student, she is I think present here today, Chetana Chaudhary of Public Health Foundation of India, shows that population density is not at all a statistically significant factor for the pandemic, although share of urban population is significant as an explanatory factor. I'm not going into the other details. And what I want to say is, as we shall see in my following narrative of development of the disease, that this extreme event of health damage of humans has in fact a neo-Malthusian message pointing to the highly damaging consequences of growing imbalance between the human system and the overall. It is also noted now, let me come to actually other extreme events which are happening or have happened in India and elsewhere. Let me mention a few of them. It is also noticeable that India has faced several cyclonic storms with catastrophic impact in recent past. The frequency of such extreme events have been growing. not only in India, but also globally. Next slide, please. Sorry. Slide 2. Next. This graph shows all kinds of extreme events: cyclone, flood, earthquake, tsunami, everything, including volcanic eruption. Everything together, how the graph has moved. You please notice that the trend is upward, although there are fluctuations, but the trend is positive, upward. India, in fact, experienced what all of us know, that one super cyclone hitting eastern coast of India in West Bengal and Orissa on 20th May, which has been unprecedented in terms of wind speed and devastation in the years since 1737 for this region. Another severe cyclone hit the western coast near Mumbai on 2nd June. The cyclones with extreme characterization and their increasing rapidification and rising frequency of incidences of extreme rainfall arise mainly because of changes in temperature on land and sea. Such extreme events render millions of people homeless, destroy standing crops and valuable plants, and wipe away the dividend of development of the infrastructure built by us over past so many years for improving the lives of the common people. India is now witnessing also another extreme event, that is forest fire. India is now also witnessing forest fires in the Himalayan state of Uttarakhand. Thousands of people are now battling the fire, which have already burned 1900 hectares in the state, where there are now 400 burning sites in the forest area. Such event is also attributable to the exceptionally dry nature of the region caused by the low rainfall. Global satellite data, in fact, shows that the frequency and scale of forest fires are increasing over time in recent years. Vast tracts of land in Brazil, Russia, Indonesia, and Africa have been burning for quite some years. Siberia in Russia is one of the coldest places on earth, and the Amazon rainforest is one of the wettest places and a major carbon storage of the planet. Both are burning at several places today, causing deep anxiety for our survival and sustainability. Indonesian forests, which are also experiencing fires, are the most biodiverse and the oldest tropical forests of the world. This is causing huge erosion of both biodiversity and environmental capital stock of the planet. The combined impact of all these extreme events is likely to be huge, if not disastrous in terms of life, asset, and livelihood. Is there any underlying reason? Is there any underlying common causality or driving factor of these disparate extreme events as experienced in India or elsewhere? Or is it just only accidental? In any case, the coincidence itself sends us a message from nature warning about the deep malady with potent, dangerous, and devastating impact that can happen in the contingent event of such coincidence. However, the commonality of the driving factors of these events that can be traced is that they are all caused by the human intervention, putting too much pressure on the nature in the form of overuse of resources or biocapacity of the local or global ecosystem. Essentially, what has happened in short is that both global heating and the destruction of natural world, that is deforestation and mainly massive land use change for farming, mining, infrastructure construction, and housing have in fact driven the wildlife into contact with humans. The destruction of habitat of wildlife and the ongoing climate change are both hurting humanity. COVID-19 being a clear warning shot. Now, let me turn to examine a bit more closely to understand the linkage of deforestation, biodiversity loss, and diseases like COVID-19. According to the United Nations, a huge total natural forest area of 290 million hectares was lost in the entire world between 1990 and 2015. This deprived billions of large or small animals, birds, insects, and microorganisms of their habitat. The consequent current rate of loss of biodiversity on land and in this age of Anthropocene is now estimated to be 100 to 1,000 times faster, I emphasize faster, than during any preceding geological age before the arrival of Homo sapiens. The modern, however, it should also be noted that apart from deforestation, climate change has also forced animals to come close to humans, which created opportunities for pathogens in human bodies, on animal bodies, to get new hosts in the human body, as observed by the Harvard School of Public Health and quoted by Guardian of the London Guardian of 25th March issue. It may be noted here, this is very important, it may be noted here that since the turn of the century, many new diseases emerged one after another, being linked to the transmission of microbes from animals, birds, and other life forms to humans. The Middle Eastern Respiratory Syndrome, which is called in short MARS, Severe Acute Respiratory Syndrome, called in short SARS, COVID-19, the avian flu, swine flu, Ebola, Zika virus, West Nile virus, etc. are all examples of such zoonotic diseases caused by the pathogens of different kinds jumping from animals to humans. But the deepest problem with these diseases is that we do not have adequate understanding as yet about the source or origin of these viruses, or the nature of their mutation and their fatality implication for the humans. It is like the throw of a dice to get the answer to any question, as the phenomenon is not only random in nature, but possibly so uncertain that the latter cannot be modeled using our calculus of probability for predictive simulations. I'm really quoting from Andrew Cunningham of the Zoological Society of London. However, now my question is, how is it that humanity has ended up in this 21st century in spite of our great achievement and ascent along the path of science and technology? How is it that we have now, after such achievement, ended up with deep problem of sustainability of existence and sustainability of our path of progress and evolution of civilization? To get a historical perspective of the emergence of the present state, we need really to look back at the history of emergence of imbalance between ecological footprint of man and the biocapacity of biosphere of our planet, which has been fundamentally responsible for the present crisis. We need to pause here and look back at the environmental history of mankind for the purpose of our understanding. I just discussed it in bare outlines. At the beginning of creation, Earth was formed as a planet in solar system about 4.5 billion years ago. Life emerged on the Earth as per the theory of evolutionary biology at least 3.7 billion years ago. There exists now on Earth at least 1 trillion different species, out of which only 1.8 million have been named as per the current state of taxonomy. These currently living species constitute only 1% of all species ever lived on this planet. The modern intelligent man, that is Homo sapiens, the only extant species of the hominid group which now dominate the earth, emerged in the evolutionary process about 3 to 5 lakh years ago in East Africa near Ethiopia and South Africa near the pinnacle point of the peninsula. These are based on the research of, I think, archaeology and genetic application of such analysis by the scientists. Of the long period of history of man, except for the last 10 to 12,000 years, humans have obtained their subsistence from a combination of gathering foodstuff from plants and hunting animals. The 99% of human history is one of man as hunter-gatherer. To begin with, they used to move in small mobile groups and followed the most successful and flexible way of life ever adapted by the humans, which caused least harm and damage to ecosystems. It enabled them to also to spread across the face of the globe and every terrestrial ecosystem in various continents, from Arctic of North Polar regions to drylands of Australia and South Africa, and also both the American continents. Mind it, this happened so many lakhs of years ago. My next question is, now let us have a look at the migration, which I just now referred to. So could you show next slide? Yes. This is one map. Here, what I would like to point out, man originating from Australia, these red as well as the blue lines, curvilinear lines, show what is being inferred by the researchers, how man moved. These are from the various archaeological evidences as found in the various caves in different continents. Now, from Africa, crossing over the Persian Gulf, went to India, and then to Southeast Asia, down to Australia. On the other hand, they went to the Central Asia, went on the one hand to the left to Europe, and again from Europe back to North Africa. And on the other hand, from Central Asia, humans moved towards East Asia, mainly Russia, the Siberia. And the next slide shows, sorry, would you please next slide? Next slide shows that you just see from, this covers the American continent. So from the Central Asia, you just see the green line crossing over this Bering Strait, entering Alaska. Man went down along the western coast and then went into the interior of North America. Went down and down through Central America, entered South America, and went up to the southernmost cape. So this is how early man actually covered the entire globe. But now the question is, how was this such migration possible for the early humans? Such earliest migration started soon after man learned the controlled use of fire and making tools out of stone, referred to the Paleolithic and Neolithic age. But it is during the period of fast glaciation and ice age that the large part of Earth's surface was covered with ice due to fall of surface temperature in many parts of the planet below 0 degrees Celsius. As a result of such fall in temperature, polar ice sheet got extended both on the north and the south of the planet, and the temperature went below the 0 degree, it went below 0 degree. As a result, polar ice sheet got extended and sea level got frozen and became shallow. This is important, became shallow, enabling nomadic tribes to cross the straits of sea at places to reach the other parts of the continent of Earth's landmass. This is how really early humans could migrate and cover really all the continents. But next question is, but why such glaciation or ice age, which come, as scientists say, periodically? It will be noted here that the ice age, so let's go to the next slide. This is due to an astronomical phenomenon. It may be noted that the ice age is a cyclical phenomenon. A period of glaciation is followed by an interglacial warm period. In fact, we are now in an interglacial warm period. The phenomenon happens due to what is called Milankovitch theory of climate. Actually, Milankovitch was a Siberian mathematician and astronomer. He lived in Siberia. Now, his theory, what he found out, it points out that among other factors, 3 phenomena is responsible. One is phenomenon of change of Earth's orbit. Look at the leftmost, the figure, that is, which is called eccentricity. The eccentricity of Earth's circuit around the sun, it varies. It is a circular to elliptical shape. In fact, when it is from circular shape, it got extended into elliptical and go up to the maximum extent, and then again comes back to the reverse, again comes back to the circular shape. One such cycle of taking elliptical shape, having the eccentricity maximum, measure maximum, with our sun as the focus, and then coming back to the old position of circularity with 0 eccentricity, it takes 96,000 years. But apart from this it happens due to the, why it happens? It happens due to the stronger gravitational pull of Jupiter, which is the largest planet of the solar system. And its mass and weight is 4% of the total mass and weight of the entire solar system.
Ramprashad, will you be taking some questions now, because there are some questions, or would you like to have them at the end?
At least let me finish.
Okay, fine.
This slide.
Okay, fine.
4% of mass and weight of the entire solar system. The climate and ice age, of course, its timing and intensity is also determined by 2 other rotational movements. Now, the Earth is moving, as we say, like a wobbling top. Now, look at the third figure. Now, the axis actually of Earth, which is making an angle of 22 to 24 degrees, its axis makes a conical shape of rotation, one such rotation in 26,000 years. This is called this phenomenon of precession. And that is why the seasons timing change over years and ages. This is one. And the other is the axis of the Earth itself, which is not a constant with the ecliptic, that the plane of Earth's movement. It varies between 22 degree to 24 degree. Again, from 22 degree, it goes to 24 degree and then comes back to 22 degree. This takes again 40,000 years, just this to and fro movement. Now let us see next big development in human history, the agricultural revolution. Now, if there is a question which is short, focused, precise question, then only I am ready to take it. Otherwise, I would prefer to take it at the end. Soumyen?
Okay.
Okay.
No problem.
It's better to put it at the end. No?
Okay, sure.
Okay. After the end of the last glaciation, which was 11,700 years ago approximately, the landscape emerged consisting of landmass of continents, lakes and rivers and seas, hills and hillocks, boulders, forests, grasslands, etc., which describe the contours of the present topography and natural map of our known world. And when ice was removed after these thousands of years, then only things surfaced. Now, there is another phenomenon which has happened. There was deposition of huge biotic masses of plants and animals under the ice sheets over hundreds and thousands of years, which contributed to the formation of humus content of soil and its buildup. Actually, I should clarify here. It is not that the last ice age what happened. Even before that, there were animals, there were plants, so they got all suppressed and went under the ice sheet. Now, when there is deposition and it gets degenerate, then actually the most degenerate state of biotic substance contributes to the humus content of soil. That is a capillary process. Now, man got soil. Not only the max was clear, but man found soil. And man, in the history of ascent of man, humankind now invented agriculture by domesticating plants and animals, cultivating land for intensive system of production of food and fiber on the one hand, and rearing cattle for milk, meat, and animal energy for humans' use on the other. Man developed tools and implements like plough, hill, etc. for agricultural activity. These developments revolutionized the productivity of both land and labor, generating surplus over the subsistence requirement of man as the tiller of soil. There now emerged settled societies with all its hierarchy and complexity. The surplus of agriculture was mobilized by the ruler or king of the society, who distributed it among the different socio-economic groups of artisans and traders when exchange started, builders of monuments, ruling class, priests and soldiers, mainly these. The early civilizations of Babylonia, Egypt, Indus Valley, China, Mayan civilization of Central America are illustrative of such early developments. But was this great transition to agriculture was without any disturbance to the natural system? The answer is that this first great transition, which itself was one should remember, which itself was a gradual process, was however accompanied by the beginning of interference of man into ecosystems of the biosphere, causing the beginning of its degradation. There was a long period when humans were partly hunter-gatherers and partly cultivators of soil. Epic, refer to the stories of epics of Ramayana and Mahabharata. There was agriculture, it's quite clear, and the agricultural wealth. But at the same time, when the Rama Lakshan or Pandavas going into exile, they are with their bows and arrows, and they are living in the forest. So it was a gradual transition. There was a long, but once man settled down as agriculturist, there emerged surplus output over his subsistence need as tiller of soil, due to the higher carrying capacity of land. This led to the growth of human population according to the perspective of classical economist thinking. Malthus thought this growth was to be in geometric progression, while food production would grow at a lower rate of arithmetic progression due to the fixity of land. As a result, there ensued long period of struggle in human history over several millennia between human number and food production, one chasing the other. This struggle resulted in the history of degradation of ecosystems of the earth in the following forms. 1. Conversion of forest land into cultivation as cropland or pasture. This triggered huge biodiversity loss. B. Intensification of cultivation by use of irrigation and fertilizer, of course organic fertilizer those days, which often in the absence of proper drainage of water in many places resulted in waterlogging and salinization of soil from time to time, and migration and wars from time to time fought for occupying land and natural resources. Most of the wars in human history are really for the command of natural resources. Its illustrations abound in history. For example, just a few. Fall of Roman Empire due to the barbarian invasion of the Huns. Fall of Byzantine Empire due to the invasion of Arabs, Turks, Slavs, Bulgars, and Normans. Invasion of Mongols in East Europe and India. What has been the environmental impact of these upheavals, as in war and migration, of these upheavals and global human mobility? It is undeniable, of course, that as humans migrated and trade emerged, it is true that the knowledge, technology, and culture got propagated and benefited humanity at large with such beginning of globalization through the early forms of imperialism. It is also true at the same time that germs and diseases spread across countries and continents with such human mobility and contact as we are experiencing today. These resulted often in extreme events of epidemic or pandemic, like classic example, bubonic plague or Black Death of Europe in 13th and 14th century, which depopulated 40% of its population. Plague had devastated, in fact, all parts of the world from time to time since before the Christian era. But did the humans succumb to this calamity? However, human history has also shown that humans finally circumvented and tided over these crises caused by shortage of natural resources and disease by the development of technology, augmenting productivity of land and labor, and discoveries of medicines, vaccines, and medical treatment and healthcare, and thus falsified Malthusian predictions of positive change. The inventions of wheel for grinding cereals, making pottery, spinning fiber, and driving cars for transportation are landmark developments in early stages of human civilization. The later innovation of machines by application of the principle of generating kinetic energy by circular motion, initially driven by renewable energy like water mills and windmills, greatly facilitated productivity of labor and of natural resources to yield social product during the long eras of feudalism in agrarian societies of medieval Europe and Asia. However, the great revolution or transition took place in human history when the use of the second great revolution of transition took place in human history when the use of non-renewable fossil fuel, that is coal and hydrocarbons-based energy and electricity, were introduced to drive machines and transport vehicles and communication equipment with the advent of industrial revolution 250 years ago. It was again another waves of revolutionary changes in human. What about now the ecological impact of this second transition? However, as in the case of agricultural transition or revolution, the second great transition in the form of industrial revolution, which began in Western Europe and spread elsewhere later, involved significant costs in terms of A, depletion of non-renewable fossil fuels, and B, pollution of various kinds, the most dominant of which was emission of CO2 gas and other greenhouse gases. The latter, in terms of carbon footprint, contributed towards more than half of the total ecological stress on Earth in terms of ecological footprint. The carbon footprint is measured by now the scientists in terms of forest land area required to absorb CO2 emission from fossil fuel, which is not the entire, which is in excess of that absorbed by normal carbon cycle of photosynthesis and by oceans. This would be in fact half of the total ecological footprint. How the total is obtained? That is in terms of human land use for all purposes to meet the whole range of demand for crops, animal products, and waste absorption. This total human footprint is measured in units of photosynthetic land area, normalized in units of equivalent cropland, with average global productivity of crop per unit of land. I've explained these things, the technicalities, in my, not the last book, the last but one book which Oxford published in 2013 about this footprints measurement. We need in fact today, actually the biocapacity was exceeded by the ecological footprint. If you look at the history of the footprint movement around in the mid-1960s. And now it has reached to such proportion, such extent, that we need actually 1.7 units of art to ensure the balance of ecological footprint and biocapacity. Mind you, more than half of this stress is due to just global carbon dioxide. Now, one interesting question which sometimes I discuss with my geologist friends is that that would the global warming due to anthropogenic greenhouse gases would impact on next ice age? While the Earth might have cycled back, or if you limit to the northern force of these, what these expensive diagram shows, it would have normally cycled back from now in another 50,000 years of time. Provided from now there had been no CO2 and GOG emission from anthropogenic sources. But in view of what is happening in the form of greenhouse gas emission, we are unlikely to see another ice age or glaciation in another 100,000 years. Because of CO2, what we would be emission, what we would be putting in the atmosphere at the current rate. This indicates the profound impact of human interference with the ecosystem of the planet, as per the finding of the, and here referring to the Potsdam Institute of Sikdar on climate impact in Germany. This institute in East Germany. But does this postponement of ice age give us any sense of comfort? There are in fact problems of uncertainty, first of all, regarding whether the impact of such CO2 emission on the Milankovitch cycle can last long enough in geologic time scale so that the postponement actually happens. However, to me, this is the wrong issue for us. What really matters to us and happening in human time scale. Even the CO2 concentration as of today is kept elevated over hundreds and thousands of years to postpone ice age. The damage that caused in the coming decades and centuries in the meanwhile due to supercyclones, floods, sea level rise, droughts, desertification and forest fires, all these, so that would be all these would be threatening the existence of humans in the present civilization. The issue is then now how to make the challenge of sustainability of human in the present juncture. So next slide. Now I would like to refer to one study, a report, which Prof Arup of Cambridge is preparing on the economics of biodiversity of the earth. The interim report has been released, 2020 has been released, and it represents the same area of ecological stress. It puts it in a different way, not instead of land use, it is also from this measure, but the way he has lucidly explained in that report is that I can derive the ecological stress just by dividing the GDP for the world or for the country's footprint, or let us use the notation Y, to the rate of conversion of resources of biosphere for supplying inputs to production and absorbing waste into GDP. That is, absolutely wonder. So what is this biological resource stock, environmental resource stock of the planet? This is the plus. These are plants, animals, organisms of all kinds. What does that mean? How do we integrate? Actually, that is why the footprint networks scientists, they try to link all uses of land and to the corresponding GDP and find out the relationship. From that really, this definition, this population has come. Now let us suppose that this rate of conversion is alpha. Now we can just take the ecological footprint with Y by alpha. Y is again, small y is the per capita GDP and capital N is the population. Sorry. Next slide. Now, on the supply side, eco-services of the earth system is determined by the stock of ecological resources of the biosphere, which is not static, which grows over time as these resources are regenerated, and these are driven by the photosynthetic process of the biosphere. Now therefore, the size of growth of biospheric resources, regenerative resources, per unit of time depends on the stock of the S at any point of time. Actually, this can be represented, growth of any period, G as a function of S. G function would be looking like an S curve, which is the logistic growth curve for any biotic species or substance.
Dr. Sikdar, sorry for the interruption, but you are 50 minutes into your lecture. So 10 more minutes.
Okay, all right.
Yeah.
All right.
Just a mild reminder.
No, thank you. The excess of ecological footprint of that is of Y by alpha over this GS is really the imbalance, and that is written in the form of that inequality. Now Dasgupta calls it as impact inequality. What is the extent of inequality as of now? This is based on the data up to 2016. Is n into y by alpha equal to 1.7 GS. We want to challenge of sustainability is that we have to now convert it into an impact equality, n by y by alpha. Now, for the long term, the durable solution of preventing such pandemic disease like COVID-19, it is therefore important that we attain the condition of impact equality, converting the inequality into equality. If we assume that the UN Sustainable Development Goal is to be by 2030, and if we take the GDP growth rate from now to that time at 3.4% rate, and the rate of decline of global natural resource stock to be at the rate of 0.3% per annum, these are the experience over the last period since 1992 to 2014. If we assume these rates of growth and decline, then such conversion of impact inequality into equality would require alpha to grow within this time span, that is time horizon till 2030, at the rate of 9.1% per annum. And alpha is to grow at 9.1% per annum. This is going to be too tall a order, given the fact that the historical rate of growth of this alpha has been 2.5% per annum. Now, the extreme events, actually now the extreme events pose serious challenges to us, and we are confronted. I'm now coming to the concluding part. Probably, I hope it will not take much time.
Oh no, all right.
Now the extreme events pose serious challenges to us, and we are confronted with a tough choice today, as we know, between life and livelihood due to the present disease, the infective nature of present disease, pandemic, which is devastating our planet. And also we are facing problem of challenge, of balance between economic growth and halting erosion of environmental capital stock of the biosphere. Now the latter leads us to a fundamental question. How can we alternatively, is there any alternative way of achieving this conversion of inequality into equality? Yes, there is one. Why can't we moderate the growth of N into Y? That is, if we can control population's growth rate, per capita GDP's growth rate, then we can moderate the growth of numerator, and that can contribute to a faster conversion of inequality to equality. But here is the really another problem. That is ability of reduction. Because the growth process is driven essentially by the capitalist force of indefinite accumulation on the one hand in the OECD countries, because this accumulation is related with political power. This is on the one hand in the OECD countries, and the developmental drive for the removal of poverty in Afro-Asia and other non-OECD countries. The feasibility of reduction of scale of economy and growth would depend on our sense of values and ethics concerning growth, well-being and sustenance of other species. These would imply our long-run policies to ensure adjustment of the human system as described by the people with their demographic, health, cultural values and preference structure on the one hand, and the scale, composition, technology and architecture of human organization on the other. All these ultimately lead to the need of setting of two goals of equality. A, we control our greed and demand by developing enlightened preference structure and level of consumption. B, cooperation of people at global and local level for equitable sharing of the benefit of use of natural resources by humanity. Since the time of beginning of settled society at the dawn of agrarian civilization, man has often tended to exceed the carrying capacity of the ecosystem and faced, as a result, problems of scarcity, poverty, war, famine, disease and devastation from time to time. All religions and faiths of the world have in fact preached emphatically for the values of sharing, charity, compassion and empathy, so that the society does not collapse due to the disorder in times of environmental crisis and humanity can sustain. I'd like to refer here to the teachings of humanists like sages of Upanishad of Vedanta, Lord Buddha, Christ, Prophet Muhammad of ancient days, to Mahatma Gandhi, Rabindranath, Vivekananda and Tolstoy of modern times. We are facing today the issues of conflict between growth and saving the nature, between life and livelihood. But meeting the challenge in the face of today's existential crisis. To meet the challenge, we need first to sustain our march of progress in science and technology, especially, I will emphasize, in the domain of genome and biomedical research today, to ensure both food and immediate health security. This has, however, to be combined with our commitment to translate the development of knowledge into that of social well-being through choice of appropriate strategies of development. But finally, all these initiatives and good actions need to be combined with our intellectual and emotional commitment to humanity for the equitable sharing of the benefit of use of global resources for sustainable human development. Thank you for your patience.
Oh, thank you, Ramprashad, for an excellent lecture. Very interesting and covering a very wide range of topics. Thank you, thank you. Well, so now it's time for question and answers. It will be better if you post them, or you may ask them. If you are audible, then it's fine.
How much time I have exceeded?
No. It's absolutely on time.
Okay, thank you. This is
absolutely
reassuring.
Ramprashad, I must say
I was worried since I am growing old, so I am possibly not be able to control my emotions and finish within time.
No, Ramprashad, let me tell you, please excuse my saying so, that over time your time management has improved dramatically. Yeah.
Okay.
Today you were just perfect, on the dot.
Thank you. Okay, now how do you do it? Will you please see the questions and read them out, and then let me. How many questions you will be able to accommodate?
I see. So can you read them, Shraddha, or?
Why don't you? I can, but you better read out.
Okay.
I'm at the moment, frankly speaking.
No, fine.
Age is putting it in print. Feeling a bit now exhausted.
Okay. So there is a question from Subal Kumbhakar. Can occurrences of extreme events be non-random and justified from sustainability point of view?
What is it? I could not follow.
Can occurrences of extreme events be non-random and justified from sustainability point of view?
Can I answer it?
Yeah.
Okay. You see, the explanation which I gave, if now these are formalized and modeled, one can show this is not entirely random. They are causal factors of linking biodiversity, land use, biodiversity, extinction of species, and then spreading of disease or contact. These can be modeled. That can be modeled only if there is non-random organism. Now we all know that all statistical analysis, even if there is a theory of explanation, there is also on the top of that always a random noise. So how to, because any theory, any model will have its limitation. So I would say that there are fundamentally, if we are unsure about ourselves, if our knowledge is not sound, then of course we will not be able to make out. We will not be able to say that, well, this is random or not random. The point is, I would believe that we will be able to, even for the present viruses, if we have not been able to discover everything about its behavior, but I think something can be found out tomorrow. At least, please remember two things. When the biodiversity habitat is exhausted, then in the ecosystem, non-linearity emerges. Split. Habitats get broken. Any broken habitat, any broken ecosystems in different subsystems induce non-linear behavior, which causes many of the trouble. Okay, let me stop here because we will require a lot of discussion. I cannot hear you.
Sorry, yeah. So the next question is from Pratip Datta, who is saying that this over-exploitation of nature and so on, aren't we, the developing countries, under compulsion to follow it in a globalized world? That is sort of capital-intensive over-exploitation of nature.
For answer, I think that that is the point. The neoliberal regime where trade and your intellectual property right regime dictate lot of things, how we will do it. What would be our policies of research and development? Now, ideally we should try to, every developing country should find their own ways out so that we can figure out the most efficient and least cost route of coming out of it. We can avoid that path of development and could possibly an alternative one. But for that we require massive, investment in research and development. And the problem is this: the political economy of scientists, of the scientific development, and the politics among the scientists. I know of experiences in my own family. In fact, somebody just suffered because of the international lobby of, creating problems, certain new innovative ways of development. Why? Because certain market of the conventional way of growth and of the conventional ways of doing things would be spoiled.
Okay. Well, the next question is from Mohan Ghosh. He is asking whether technological solutions, negative emissions technologies such as direct air capture and storage and ocean fertilization, will these help?
Well, I have discussed these issues with researchers some researchers in the Canada area. They are trying to make this carbon capture and then convert it in liquefied form under the ground. So there are, first of all, there are risks, and as yet it has not come to that stage that you can depend on that as a Indian rule always found. But we also hope that possibly that research should also be carried on, and if that becomes viable, it can give some viable, economically viable results, it will be done. Because when I discussed these things with some of the scientists in Canada, I remember in Calgary. Calgary was the once upon a time energy capital of Canada. So they were working on these carbon capture. What I gathered is that we wanted to go a long way.
And the next question is from Shamik Rai. Since consumption habits are historically irreversible, don't we need to focus more on environment-friendly goods with active intervention of the government?
Well, the history of government intervention has been mostly it has failed because of the business lobbies. Discouraging has just been that the business was concerned. Now, what was the question of? Could you repeat?
Sorry?
Would you please repeat the question?
This is, don't we need to focus more on environment-friendly goods with active intervention of the government?
No, no. The point is this. Yes, of course. But the point is this: how would you ensure what are the environmental friendly goods? There will be a global competition of investable capital, that what can we obtain by investing in those areas, who can capture what ideas on these new innovations. Now, unless there is really government guided research in inventions and innovations of food and science, it will not be successful. Say, there is this a very controversial issue is the genetically modified food. Even this morning I was talking to my one colleague,
Ramprashad Sengupta
in AACUED on the genome research, that genetically modified comfort. So the whole propaganda about the risk is really by, I have heard this earlier also several times, by the pesticide and fertilizer law. They would not allow this thing to come. Although there are issues of biosafety, and for that the rigid monitoring of the state is required. But if it is done, what is required our goodwill and honesty. The problem is there.
I request you to suggest some concrete solutions. Some concrete solution
Of what?
of the problems that you have mentioned.
Well, to control our greed.
Right.
Listen to Bhagavan Buddha's speech.
Or Gandhi. Or Gandhi.
Mahatma Gandhi, right. Now, unless we think, in fact, there are every evil event has also a good side. Whatever we learn during this pandemic, we can manage with much less consumption. I know every one of us, many people agree. So we have so much of wasteful consumption, wasteful travel in the city. We take too easy. These are almost people, and there is no health risk. We have given such a slap on our face by nature, because violating the free population and limits, that we have learned this. So I think one and change the preference structure. Not that we have to stop. We have to change the preference structure. There is another. You look at the history of suffering. I think the parallel history of famine, history of disease, and history of war. These can be analyzed side by side. Interestingly, the history of overconsumption, right? And because of overconsumption, wasteful use of intermediate input sources, intermediate process waste.
Well, Vishal Shandal also wants you to give some prescriptions to ensure equitable distribution of income. That's a very broad question. So, how to ensure equitable distribution of income?
This has been a problem right from the beginning of human civilization.
Right.
As soon as settled societies emerged in agriculture, where you are, at the bottom, the slave or serf or the pillar, above them are the fighter, warrior, on the one hand, artisan, builder on the other, and then above them are the priests and at the top, the thing, the name tag. Now these have got how these are partly by on a day who will already occupy what. That is wrong. Economic political power what each group can mobilize in their own case. But of course, in the history, from time to time, some of these social economic groups who have been oppressed, too much exploited, they have resented somehow revolutions of people. Look at all the histories of the revolution in Europe and elsewhere. So the point is this, that inequality in revolution is really, it is not, not really for me to say, well, tomorrow let the government of India do this. But one thing, the inequality is the source of all kinds of not just ecological stress, but also social stress. And I just stopped this question by referring to my last book, which has just come out at the onset of this pandemic. This is the Entropic Law, Sustainability and Industrial Revolution.
It is latest, not last.
It is the latest. It is latest. Right. You think that I should leave for some more time? Of course. Now, it is the latest, and there is a long chapter on this inequality, poverty, and social crime and inequality, and made some with data, some economic analysis also of crime, including riots and polarization, all aspects. So, I just deliberated something there. It's such a big problem. I think Ashish has also done, Ashish Banerjee, I think, who is an art today here. Recently, his book has come out on inequality. He would possibly be a better expert on giving prescription or solution. Okay, next one.
Okay, here are two compliments from Professor Ramprashad Chair and Professor Ramprashad Mukherjee. They think you have done an excellent job and that Arup Mallik would have enjoyed your talk hugely.
Thanks to them. Most welcome. In fact, I was recalling that if this had been, while I am writing this, I was thinking, if this had been those days of service, surely I would have one day rushed to his Manikala house and just check, is it making sense?
But Ramprashad, you must remember that that building doesn't have any lift. You will have